These are the frequently asked questions for Algebra 2 for section 9.5 day 1. And it says evaluate the sum of the finite geometric series. So if it's finite, I start thinking in my mind, all right, let's see, that's the one that has a sub 1 times 1 minus r to the n over 1 minus r. And I see that geometric series up there, and I realize I don't know what n is. You know, I certainly know what the first term is, and I'm looking at this and I realize that if you take 2 divided by 1, you get 2. 8 divided by 4 is 2. 4 divided by 2 is 2. So r is 2. I've got that. But I need to know which one that 128th term is. So that means I need the rule. And there is our geometric rule. So a sub n is going to equal 1, the first term, times 2 to the n minus 1, which is really just a sub n equals 2 to the n minus 1. Now, I want to find n, and I know that it needs to come out to 128. So, two things we can do at this point, because we haven't learned logarithms yet. We can basically try a trial and error piece here. So, we try 2 to the 9th is 512. So, you know, too big. So let's try 2 to the 8th. 2 to the 8th is 256, so getting closer. 2 to the 7th is 128th. So if this is going to come out to be 7, that would mean we have to put an 8 in there. So n is 8 will give you 128. So this is the sum of the first 8 terms, where the first term is a 1. The common ratio was a 2. Again, n is 8, divided by 1 minus r. Well, 1 minus 2 is just going to be negative 1, and 1 divided by negative 1 will be negative 1. So I just need to punch in 1 minus 2 to the 8th. That gives me negative 255. And multiply that by negative 1. So the sum of those first 8 terms is going to be 255. You can see how this is similar to what we did with arithmetic summation. You know, we'd have to write the rule in order to get the things that we needed to use them in the formula. Then, let me go to number 12. And for number 12, this is in that summation. Number 12 has a sum from n equals 1 to 5 of 3 to the n. Now, while we have that 3 to the n, which basically is written as the geometric rule, we start thinking, okay, this is a little bit different, because it is. The rule is not in that a sub 1 times r to the n minus 1 formula, but we still know what r is, and we can certainly figure out what the first term is. So we want the sum of 5 minus 1 would be 4, but then you add 1 so that you're counting that n equals 1. So we're talking about 5 terms here. The first term, we're going to get that by putting a 1 into the formula. So 3 to the first power is going to be 3. And our r value is 3. And again, n is 5. And then on the bottom, we need 1 minus r. So this will give us 3 divided by negative 2. So negative 3 halves times 1 minus 3 to the 5th. And again, good time to just grab the calculator and punch this in. And I always follow the order of operations. So we can do the 1 minus 3 to the 5th. And then multiply that times the negative 3 halves. And it is 363. So that's the sum of those first 5. So we treat it a little bit differently when it's not following exactly the format that we need. Speaking of not following the format that we exactly need, here's another one with number 13. But again, we can find it. So 4 minus 1 plus 1 to figure out how many terms there are, and that's going to give you 4. And then the first term is found by putting a 1 in for n. Well, 1 plus 1 is 2, and 1/2 squared is 1/4. R is what's being raised to the power up there, which is 1/2. And we're going to raise that to the 4th power. All over 1 minus r, which is 1 minus 1/2. So we're going to end up with 1/4 divided by 1/2. And remember, with fractions, we don't multiply, we don't divide, we multiply by the reciprocal. So that's going to give us 1/2 of 1 minus 1/2 to the 4th power. So get this all punched in. 1 minus 1/2 to the 4th power. And then that answer times 1/2. And let the calculator convert that back into a fraction for you. So the sum of those 4 terms will be 15/32. All right, next one on the list. Number 16. In March, a family starts saving for a vacation. They're planning for the end of August. The family expects the vacation to cost $1,375. They start with $125. So right away, I'm thinking about how they're going to get a rule to figure out how much they have each month. And it says they plan to deposit 20% more than the previous month. So they have 125, but this is going to be geometric because when you find percentages, you're going to multiply. So that's going to be times 1.20 to the n minus 1 power. And then it says, will they have enough money for their trip? If not, how much more do they need? Well, they're starting in March. So they want to plan this vacation for the end of August. So that'll be March, April, May, June, July, and August. So that's going to be 6 months. Since it's at the end of August, we want to count that. So n is going to be 6. And we want to figure out the sum after 6 months. Is that going to be enough? So a sub 1 was 125. And we're going to need 1 minus r, which is 1.2. And 1.2 will be to the 6th power. That's a little hard to read. Let me redo that. Over 1 minus r. So we have 1 minus 1.2 on the bottom. That's going to be a negative 0.2. So 125 divided by a negative 0.2 is negative 625 times 1 minus 1.2 to the 6th power. So let's see what we get. 1 minus 1.2 to the 6th power, and that times negative 625. $1,241.24 is what they will have after the 6 months. Well, they needed $1,375, so the answer to the question is no, they don't have enough money for their trip, and they want to know, if not, how much more do they need? Well, they're going to need to take 1,375 minus $1,241.24 to figure that out. So 1,375 minus 1241.24 is $133.76. So they'll have to figure out a way to get a little extra money to go on their trip. Let's see. Next one on the list. Takes a little bit to get into. There we go, 33. Determine whether each series is arithmetic or geometric, then evaluate the finite series for the specified number of terms. So I have to be careful here and recognize which one it is before just jumping in. And with 33, the first thing I check is this arithmetic? And it certainly is, because they're adding 2 each time. So for 33, I just start right away by writing my rule. So a sub n is going to equal 2 as the first term times n minus 1 times that common difference of 2. Distribute from the right-hand side, and we get a sub n equals 2n, which certainly makes sense if you go back and you look at the sequence of the series itself. You see those numbers 2 times 1, 2 times 2, etc. Now, I want the sum. And again, we have to go back and use the arithmetic sum formula. And it says that n is 20, so we want the sum of the first 20 terms, where the first term is a 2, and now we need the 20th term. Well, that's the whole reason that I went ahead and wrote the rule, because we can find it very easily. 2 times 20 is 40. Divided by 2 is going to give you 10. So 10 times 42 is 420. So you recognize which type of series it is, and then pick the correct rules and formulas to use with that. Now, let's go after number 37. Number 37, I notice it's definitely not adding the same negative value each time. That doesn't make any sense. So the next thing I do is I check to see, is this geometric? And all of those will reduce to 1/3. So this is geometric with an R value of 1/3. So 37, geometric. And a sub n equals a sub 1, which is 81, times r, 1/3 to the n minus 1. And then I start thinking about what they want me to find, and they want me to find the sum. So the sum of the first 200 terms, I have to use my finite geometric series formula. And I need the sum of the first 200, where the first one is an 81, times 1 minus, well, we have 1/3 for our R value, and that needs to be raised to the 200th power, all over 1 minus 1/3. All right, so the sum of the first 200 comes from, we'll do 81 divided by 1 minus 1/3 is 2/3, so 81 basically times 3 halves, but you can get this to be a little bit easier to punch in just by doing that step. So that is 243 over 2, or as a decimal we could use it as 121.5. All right, so let's see how goofy this answer is going to be here. 1 minus 1/3 to the 200th power, and then we need to multiply that times 243 divided by 2. And number 37 is kind of interesting, because when you do 1 minus 1/3 to the 200th, you get 1. And then 243 halves times 1 is 243 halves. Since we're summing these numbers, since we're finding the summation of all of these, this is where we usually will just go with a decimal, especially if it's nice like this one, 121.5 for the sum of those 200 terms. So kind of an interesting little problem there. Then, I believe there was some review problems I wanted to go through with you. It says, what's the value for the sum from n equals 1 to 5 of 2n minus 3? And I notice that is linear because that is a first power, first degree expression. So what I want to do now is think, all right, well, this is arithmetic because it is first power. So what am I trying to find? Well, 5 minus 1 plus 1 will be the sum of the first 5 terms. And like we said, if this is 1, then you can just take the upper limit. It's just not a habit you want to get into immediately going to that. You always want to check and see. And to find the first term, all you have to do is put a 1 into the formula, and that'll give you negative 1. And then to find the last term, put a 5 in. 2 times 5 is 10, and 10 minus 3 is 7. So this will be 5 halves times 6, and you could write that as a fraction, do a little cross-reducing here, to get 15. So there it is. And you could argue with this one, hey, I could just put the 1 in, the 2 in, the 3 in, the 4 in, the 5 in, and then just add them up. I mean, the numbers are small enough here where that wouldn't bother you, but we certainly do want to use the formulas whenever we possibly can. 59 says evaluate each series to the given term. All right, so what I'm trying to figure out is this arithmetic? Is it geometric? What's going on here? So from $12.50 to $15, we're adding $2.50. From 15 to $17.50, again, we're adding $2.50. So I notice this is arithmetic. So a sub n equals a sub 1 plus n minus 1 times d. And the first term was 12.5, and that common difference was that $2.50. So 12.5 plus 2.5n minus 2.5, that will be 2.5n plus 10. Worked out really nice there. And then we do want the sum. So we need to grab the formula for the sum of an arithmetic series. And we want 7 terms, where the first term was 12.5. And we need the 7th term. So that's what this rule was built for. So we need $2.50 times 7, and then we need to add $10 to that, and that'll be $27.50. All right, so $27.50 going into our formula. So now we'll just punch this in and see what we get. So we have our little $27.50 plus 12.5, and then we will take that times 7 halves, and that is 140. So the sum of those 7 terms in that arithmetic series is 140. Now, 61 says add or subtract and simplify where possible. And you look at 61 and you realize, oh, I can't just go ahead and do this math. I don't have a common denominator. So what we want to do is take the original. And remember, we can build up our denominators. We just have to make sure that whatever we do at the bottom, we do at the top. So this first one is going to need an extra c. And what you do to the bottom, you do to the top. And the second one is going to need a 2. So that will give us 7c over 2c squared minus 4 over 2c squared. And now we have a common denominator, 2c squared, and we can go ahead and do that subtraction. The bad news is that's all we can do. That's it. 7c minus 4 has subtraction in it. We cannot factor anything out of that so that we can cancel. It's done as it is, so we're getting that common denominator. And that's basically what that activity was all about anyway. Now, this says graph each function. I'm going to grab some graph paper here. All right, now I have graph paper and I'm all ready to go. And with 67, I notice the parent function here would definitely be just y equals x squared. And that, of course, is 0, 0, 1, 1. 2, 4, etc. And using symmetry, equal but opposite on the other side. So this is my parent function. Hardboard is still graphing a little high here. And I need to move that down 4 units. So there it is. So just reminding you of how to graph basic quadratic here. Number 68, with that one, what we're going to want to do, because it's not in an A, H, and K format, is remember that to get the x-coordinate of the vertex, you use the little formula negative b over 2a. So negative 6 is our b value. The negative of negative 6 would be 6, and then a is a 1 here, so that would give us 3. And then we can go ahead and put the 3 through the formula in order to figure out what the y would be. So 9 minus 18 is negative 9, and negative 9 minus 9 is another negative 18. And I'm going to have to make my little graph go by 2's here if I am going to fit that on there. So 3, negative 18 would be right there. Now, another thing that would be really, really nice to do would be able to figure out where the zeros are, and then I could just draw in the curve. So x squared minus 6x minus 9. I start to think, do I have two numbers that multiply to negative 9 and add to negative 6? Unfortunately, it isn't going to happen. So I might just have to go ahead and put a couple of extra points in here and see what I get and use symmetry. So let me try 2. So I put 2 into the formula, and I will get 4 minus 12 minus 9. 4 minus 12 is negative 8. Negative 8 minus 9 is negative 17. So I'm not getting a whole lot of anywhere by putting that 2 in there and using symmetry. So how about if I try something like 6 and see what happens? 6 squared is 36, so 36 minus 6 times 6 is 36 minus 9. Looking a lot better there, so 6, 2, 4, 6, negative 9. And symmetry, equal but opposite on the other side. And that is enough for me to see the curve here and get that drawn. So there it is. All right, then number 69. Let me go ahead and change this one. Again, not fitting our A, H, and K formula, but we could certainly use the parent function of y equals negative 4x squared and go from there. We just use some basic numbers and remember that we have symmetry. So maybe 2, 1, and 0, we'll use those. So I put a 0 in, 0 squared is 0, I'm going to get 0. Put a 1 in, negative 4. Put a 2 in, and we'll get negative 16. And I think I'm just going to go by 1s on this particular graph and see what happens. And I need to move that over. So let me erase and get this graph where you can see it. All right, so this is our parent function. Right here. And then behind it, we have a plus 1. And that means all we need to do is move this graph 1 unit up. So we take those few points. Uh-oh. And move them up. And there it is. So a little review on graphing there. And that should do this.